All right, hey everyone. Welcome back. This is Mrs. Nelson, and today we're going to be talking about. I know this looks kind of small, but we're going to be talking about how can I perform operations with functions. So Mrs. Wortman yesterday would have walked you through just some basics about functions, just some things that you're going to need to be able to use for not only that day, but kind of the days to come. So today we're going to be talking about what it looks like to actually do things like adding, subtracting, multiplying, and dividing. So you want to go ahead and annotate your essential question. Uh, those are the four main functions that we'll talk about today, and then she will be walking you through some things for tomorrow. So the best format for this lesson I thought was to set it up as a Freyer model. So you would want to maybe just draw the four corners that you see and then just have like a little section in the middle. And it says we're going to be using the operations that are listed in each of the corners to perform some different operations with these three functions. So I have f of x, which is x squared minus 5, g of x, which is 4x squared minus 3x plus 2, and then h of x, which equals 3x plus 2. And I'll be kind of using a mix of those three functions just to kind of give us a little bit of variety. So I'm going to actually start with the addition. And so just a intro into the notation that you'll see. So if I'm adding two functions, you would obviously expect to see an addition sign, and it may group them together in one set of parentheses. So basically what that means is we're going to be taking whatever f of x equals and adding it to whatever g of x equals. And so then whatever f of x equals, which in this case equals x squared minus 5, I will put in that spot. And then whatever g of x equals, which is this whole, so if you want to use parentheses, you can, which is the 4x squared minus 3x plus 2. And then from there, sorry, I'm just going to make some adjustments here. From there, I don't really need the parentheses because I'm not doing anything like maybe what we would talk about for subtraction. So now it's just a matter of me combining some like terms. So I would maybe find other terms that have the squared component. So that would actually turn out to be 5x squared. And remember, the exponents don't change when we're adding or subtracting. There's nothing that can combine with this negative 3x, so we're going to just bring that down. And then I can combine the negative 5 and the positive 2. So that would end up being minus 3. And so if I'm looking at adding two functions, it basically means that whatever they're equivalent to, you're going to add together and then just combine the appropriate like terms or perform the operation that is there. So let's head into subtraction. So I'm going to scoot this over. If you need to pause and before you move on, feel free to do so. So for subtraction, we're going to do, let's just switch it up. So I'm going to do h of x minus g of x. And so the notation that it would have looked like before, I got a little ahead of myself, would be h minus g of x. And so all that means is we're going to be taking whatever h of x equals and then subtracting whatever g of x equals. So again, I'm going to write out the two functions that I have. So h of x is 3x plus 2. Now in this situation, using parentheses is a must because I need to make sure that I appropriately subtract all of the components that are a part of g of x. So the parentheses is going to make a difference in this scenario. So what that means is, and maybe if you want to have parentheses there, that's fine too. But this first set is not going to change. However, this subtraction needs to be applied to all three of the components that are being subtracted. So now this is really going to turn out to be negative 4x squared, a negative negative, so subtraction of a negative means addition, so positive 3x, and then subtraction of a positive means subtraction again. And then just like we did over here with addition, I'm going to look for things that can be combined. So I see these two, which is going to give me 6x. This negative 4x squared is just going to combine with nothing. So I'm going to put it at the front just as kind of a standard way of writing it. Then put the plus 6x. And then the 2 and the negative 2 is actually going to equate to 0. So I don't need to fill in plus 0, but if you want to, you can. So if I do h minus g of x, this would be the appropriate outcome here. I'm going to go ahead and move on to multiplication. So if you need to press pause, please feel free to do so. All right, so same kind of setup for multiplication. Let's see here. I'm going to pick, let's do f of x times, so I'm going to use the multiplication symbol, the dot. And let's do f times g of x. Now I know this is going to look a little intense, but basically what this means is that I'm going to take whatever f of x equals and multiply it by whatever g of x equals. So f of x, I'm going to maybe scoot my work over here. F of x is this x squared minus 5, parentheses. And then my g of x has 3 components. So minus 3x plus 2. Okay, now I can't use the phrasing FOIL because I have more than 2 components here. So I am just going to have to kind of go through and distribute. So maybe with a different color, I'll try to separate the different pieces. So I'm going to start with taking x squared and multiplying it by all 3 of the components in the second, parentheses. Remember exponent rules, so if I do x squared times 4x squared, that's going to give me 4x to the 4th. If I do x squared times negative 3x, that's going to give me negative 3x cubed. And x squared times positive 2 is just going to give me positive 2x squared. Okay, now I'm obviously not finished. I need to keep going. So I'm going to use this pink one. And I'm going to repeat this now with the negative 5. So just kind of make sure that I'm multiplying it by all of those components. So negative 5 times 4x squared is negative 20x squared. Negative 5 times negative 3x is going to give me positive 15x. And then negative 5 times 2 is going to give me negative 10. And then from here, it's just a matter of, just like we did before, looking for like terms. Again, like terms imply that the exponents are the same. So these two right here, I don't see anything else that can be combined with those. So those are going to stay. I do see these 2 components which can get added together. And then these final 2 terms are just going to stay as is as well. So I have 4x to the 4th minus 3x cubed. If I combine these 2, that's going to give me negative 18x squared. And then I'm just carrying down the other 2. Oops, sorry. So plus 15x minus 10. If I went too fast for you and you need to slow it down, please feel free to pause and then backtrack. All right, so we have one more operation, and that's going to be division. Now, we don't have a lot of background knowledge on division. We'll get to that in a later chapter. So what I'm going to show you is first the setup, and then we'll maybe talk about like if I want to change the input. So let's maybe do f divided by, let's do h of x. And so the setup would look like this. So what that really means is we're going to be doing whatever f of x equals divided by whatever h of x equals. And so if f of x is x squared minus 5, that goes on the numerator. And then if h of x is 3x plus 2, that goes on the denominator. And then because of what we're going to learn later on in the trimester, this is as simplified as this can get. So this would actually be your final answer. Let's just, for the sake of incorporating some of the things that you did in the previous days. If I asked you to find f of h of, let's say, a number like -2, then all that means is in this previous answer where we're showing the division, wherever I see an x, I just have to replace it with -2. So I'm going to do that. So in parentheses, I have -2 squared minus 5. And then on the bottom, filling it in both places. Be careful with typing this into your calculator. So when you type this in, please use parentheses. So that would actually end up giving you +4 minus 5. And then -6 plus 2. This top is going to be -1, and then the bottom is going to be -4. And then simplifying that, just because I have a negative over a negative, would end up giving me 1/4. So that just is an example of what it looks like to switch it up. Again, feel free to backtrack. Your Google form for today is actually going to be you coming up with your own Frayer model. Let me just back this up. I will post a copy of this if you want to print it. Otherwise, just set up 2 different lines on a sheet of paper, and then you are going to write 3 of your own functions. I would suggest making them similar, maybe just with some different numbers, labeling them as f of x, g of x, and h of x. And then just like I did in the previous examples, I would go through and just perform the different operations, and there are instructions in the Google Classroom assignment for how to upload this picture. Please reach out if you have any questions, and thanks for tuning in today. I hope you have a good day.